Today we are going to continue talking about properties of exponents. Specifically, how do we simplify an expression when the expression has a negative exponent in it? So a lot of times the directions will say simplify, write with all positive exponents, or something along those lines. Please note that when the directions say simplify, the second part of these directions are implied. So if you're asked to simplify an expression using properties of exponents, know that you are going to ultimately be writing it using all positive exponents. So let's look at this example first. What if we were asked to simplify x to the negative third? Well, there's nothing else to combine with that term. We do have a negative exponent, so we're going to treat that as a fraction. And you can multiply anything by 1 without changing the value. 1 is the multiplicative identity. If you multiply 10 by 1, you get 10. So we're going to multiply by a version of 1 that is helpful. Well, if we multiply this by x to the third over x to the third, x to the negative third times x to the third is x to the 0th. We would add the exponents. 1 times x to the third is x to the third. X to the 0th power we've already established is 1. And so that simplifies to 1 over x cubed. That is our simplified expression. Next example. What if it started as 8x to the negative second y cubed over 12x to the fourth y to the seventh? All right, a lot of you would be looking at that and saying, wow, there's a lot of terms in that problem. There's a lot of values being multiplied together and divided, and there are. So what I like to do is split this fraction by multiplication. So could we treat this as 8/12 times x to the negative second over x to the fourth times y to the third over y to the seventh? Yeah, we can, because we can, if we multiply all of that back together, we'll get back to where we started. So we didn't change the meaning of that problem at all. 8/12 is a fraction that both have factors of 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So we can just simplify that fraction using properties of fractions that you guys have been doing for years. This x to the negative second over x to the fourth, we're going to multiply by a version of 1 so that we're not changing the meaning, we're just making it look different. Okay. So we'll have 2/3 times x to the 0th over x to the 6th. Now let's take care of these y's. There are more y's being multiplied together in the denominator. So I'm going to split y to the 7th as y to the third times. We accounted for 3 of the 7 y's there, so we need 4 more being multiplied there. Y to the third divided by y to the third is 1. So we're going to have 1 over y to the fourth. Okay, now we get back here, and we're just trying to condense these back into a single fraction. X to the 0th is 1. So in the numerator, we really have 2 times 1 times 1 over 3 times x to the 6th times y to the 4th. 2 times 1 is 2. And 3x to the 6th, y to the 4th. That is our simplified expression for that problem. I'm going to go through one more problem with you guys here. The quantity of 3x to the negative fourth y cubed all squared. So we've got 3 values being multiplied together in these parentheses, the 3, the x's, and the y's. All of them need to get that power of 2 applied to it. So that's going to become 3 squared x to the negative 8th y to the 6th. Now we've got this x to the negative 8th, so we need to treat this as a fraction so we can put it over 1. We're going to multiply by a version of 1, x to the 8th over x to the 8th. So we'll get 3 squared, which is 9. X to the 0th, x to the negative 8th times x to the 8th, add the exponents. Y to the 6th over 1 times x to the 8th, which is x to the 8th. And x to the 0th is just 1. So that will become 9y to the 6th over x to the 8th. And that is our simplified expression for that problem.